So this time I'll put the machine into a pause mode, so you can see it go through each of the steps. I'll break it, put a heat shrink on it. These heat shrinks are easy to maintain on the machine with its easy to use menu adjustment for the heat and time. This time I'll put it into a pause mode. Change it to step, overwrite. It'll bring it in and then it'll pause at each step. So now we can check the cleave angles, 0.6, 0.6. Total angle 1.29. One of the curious things about the fibre is that if you rotate it, so where there was 0.6 and 0.6, I've now rotated it about 90 degrees. So now it's 0.5 and 0.5, but the total is 0.1. So that's just by orientating the fibre. Not that you would normally do that, just out of interest, so you understand the left and right angle and the fact that they come up with a total. Excessive total is going to give you a poor splice.
What's an excessive total?
4 degrees.
What's an ideal total?
Ideal would be, like perfect would be less than 1. Excellent is less than 2. This is your combined angle. And combined angle of 3 is still going to be fine. We've actually done tests and taken it up to 6 degree total and still end up with below 0.1 dB loss. So on core alignment machines on single fibre, it's easy. So we've got X view, Y view, X and Y vertical, X and Y horizontal, and each one of these allow you to zoom. So from here we can hit the play button. It'll go through the splice and then it'll give us a set of readings. So the reading there is 0.01. These are a calculation based on the geometry. As you can see on the machine, the splice loss, let me just untangle the extra pressure. Yeah, it's similar. So we typically end up with a lower loss in actual fact against what the machine is displaying.
So the machines are somewhat conservative.
There are some machines that will tend to show you 0 all the time, and they've just designed their calculation to be on the favourable side. It makes the machine look good and it makes the splicing look good, but you end up having to go back and do rework. We like the idea that we're showing a negative view, so the technician, when he can look at the image, he can just decide whether that's a good splice or not. So if the technician is looking, he can zoom in on the actual fibre. and get a good clear view, and he can decide himself whether he thinks it's lined up properly. In this particular case, we have a very slight step, so it goes step, bend, mode field diameter mismatch across the first three figures there. If it's a mode field diameter mismatch, it's not going to change. It doesn't matter how many times you break and resplice it, because it's two mode field diameters. If it's a bend or a step, you can break and redo it and get a better result, or a worse result, depends on the splice. So we'll let it go through the tension test now. We'll slide the heat shrink up, get the heater ready. At the time that you do the splice, the heater is preheating, and by the time you close the lid, it's already got some heat into the machine. Oop. That was closing the lid in an auto mode. So it's the heater running. Pop it out of here and let it cool. We're ready to do another one.